Hi everyone. Thank you, Mr. Kumaran, for your sharing input on BIM. Okay, I will continue from here. Okay, I will share my screen. I'll share my slide. Okay, today I would like to share with you guys the BIM process, specifically for infrastructure works, inside from the construction side. Okay, so just now Mr. Kumaran's already explained to us, sharing to us the input what BIM is, but now I will elaborate more specifically for infrastructure. Okay, so today this is the agenda. What I'm going to share with you is what is the BIM for infrastructure, some demonstrations, sharing section. Sharing section might be our previous project and sharing all the projects that have done before, and also the Q&A. Okay, I hope everyone can see my screen and can hear my voice. Okay. Okay, first is a BIM for infrastructure. Okay, BIM for infrastructure, in any project, either building project, railway project or other project that's related to BIM must come with infrastructure element first. Okay, so what's our contents in infrastructure element? They will be road, rail, bridge, building platform, you can see here, utilities underground, okay, like sewerage, water supply, all the telco line and others here. And then the water areas, tunnel, and the last one is the drainage or the channel, and also the channel, okay, for the construction. Okay, next is, okay, I have a video showing you overall that BIM for infrastructure. Maybe I can share to everyone. Let me play this video.
In today's civil engineering, traditional ways of working are often insufficient. While some industries have embraced digital transformation, the move to enhance the process of planning, designing, and building infrastructure continues to lag. Firms still maintain traditional systems and outdated 2D processes, resulting in increasingly complex projects while exacerbating budgetary and schedule pressures. Take road maintenance. Traditional methods to mill and overlay can lead to large overages due to design process limitations. Even worse, roadways can remain out of design tolerance after maintenance, resulting in deficient road conditions and safety concerns. Complex projects, while exacerbating budgetary and schedule pressures. Take road maintenance. Traditional methods to mill and overlay can lead to large overages due to design process limitations. Even worse, roadways can remain out of design tolerance after maintenance, resulting in deficient road conditions and safety concerns. In bridge design, workflows often involve different complex applications that are not highly interoperable with each other, causing significant loss of productivity due to the start and stop nature of project cycles. Digital transformation brings new ways of working by making accurate design data and intelligent design models persistent throughout the project and operations lifecycle. You can now work faster and make more informed decisions. You can put stakeholders at ease with better coordination. And everyone can collaborate with greater design efficiency to dream and generate inspired solutions to complex challenges.
Okay, now we're going through to the infrastructure 3D BIM model benefits. Okay, I just want to share a quick benefits that what you can have by having a 3D model, by creating a 3D model from the design informations. So first is allowing more creative room. Okay, let's say task is getting easier nowadays. Okay, since the technology now is the technology is more advanced, like kids in 2 years old already know how to operate their handphone. So that's how this technology advanced in our life. So it also makes it easier to visualize whatever ideas that we have. Okay. Okay, number two is easily shareable design. Okay, in three with the 3D model, it make easier to share the design remotely and let immediate feedback. So let's say if we have any issue on our design, we just send the RFI by using our 3D model. We can detect earlier rather than we bring in the construction site. Then during the construction, then we define is they have a clash. So there's no other way instead of you have to hack the site, the construction. Okay. Okay, and then number three is identifying problem earlier. Okay, like I just said just now, we with the potential is of the 3D model, you have more time to play around with your design and you can experiment it. And then you are able to identify the potential problem before construct a site. Okay. Okay, number four is making greater team collaboration possible. Like if you have more than one discipline, let's say if let's say a building construction, okay, they have architecture, they have M&E, they have a structure. So how they want to collaborate by using a single platform, which is a 3D model, you can collaborate and coordinate that information easily. Okay, and then number five is experiencing the project before it's built. Okay, by using the visualization that you already have the visualization, you can see around with the design. Even architect also will not crack their head to think how they want to design this, how to design this if it's in 2D. So the imagination it's clear with the 3D model. Okay, so that's the five item, but five benefit that you can see from the 3D model. Okay, then I will go straight to the demonstration. I will do some demonstration specifically for infra. Okay, here the scenario. I just create one scenario for the project summary. Okay, the project owner, I just put in one name, ABC Public Work Department. And then the objective for this project to propose a new bridge and upgrading an existing road for industrial area. Okay, if you look at here, actually this is the area that we're going to create the 3D model by having all this information. Okay, we will recommend the best platform level for building at industrial area. Okay, and then we going to propose a new design for utilities underground and do some clash analysis to because currently they have a area that already abandoned for quite some time. So they have a lot of existing utilities underground. So we have to create a new one for our new development. And we have to do some clash analysis to make sure there is no uh, obstruction for our new line. Okay. Okay, so for the project deliverable, we're going to have a bridge and road 3D model. Okay, we will have the grading for proposed new level and plus with the cut and fill area and the volume. Okay, and last one if is a new design for pipeline and the clash detections. And okay, for the workflow, in the project planning, what we're going to do in the project planning, normally we will define the project extent. Okay, how long it going to take and how many persons will involve in this project. Okay, and then second one is establish the analyze existing conditions. So before we start, we have to see what are the possibility of the site, or maybe there's a existing route that we can propose the new route, continue from the existing or others in the existing condition. Okay, so the number three is a create and analyze multiple conceptual design option. Okay, in InfraWorks, okay, they have one tools in been for infrastructure process. They have one tool called InfraWorks that allow you to create the multiple option for the design. So you don't need to create one and then you present. After that, your boss, your client, sorry, your client said, do they want to make some changes, or give another option? So you already have the options. Okay, so you can have more than one design. Okay, number 4 is select the best conceptual design and to move into the preliminary design. Okay, once the client said, okay, this is the design that I want. This is the design I decide I want to choose this design. So we just bring this planning information, go to the another software or another tools to create the preliminary design. Okay, in preliminary design, we're going to, for specifically for this project, we're going to design a bridge and upgrade the road within the ROW, is a right of way. Okay, and then we're going to design a proposed new line for utilities underground by identifying the existing. And then we propose the best level of building platform. For balancing the cut and fill, we're going to run the before you go into the detailed design, we will propose one level. Okay. Okay. In detailed design, we're going to design a cross section of the road bridge from preliminary model. Okay, for prelim model just now, we will bring it into one more tools called as a Civil 3D to create the detailed design. Okay. Okay, you will have the in design, you will have the cross sections with the volume. Okay, so the number 2, you can run the clash analysis for existing and proposed utilities underground. Okay, we can have that for the new line and perform cut and fill. Okay, so you want me to okay. It's okay, maybe I just proceed first. Okay, and then the final output what we can have from this 3D model is a detailed design for infrastructure elements and cut and fill volume. The proposed utilities will be clear from clashes. So that means our proposed new line for the utilities underground will be clear from clash. And then the proposed level for new site with balance cut and fill. So you can have function in Civil 3D to balance the cut and fill volume. Okay. Okay, now we go straight to the live demonstration. Okay, I will open in Autodesk InfraWorks. InfraWorks is a tool for creating preliminary design. I hope everyone can see my screen. Is it okay? You can see the InfraWorks? Or you still at slide? Okay. So this is InfraWorks. Okay, in InfraWorks, actually you can create the prelims model. So you can rotate, you can zoom in, zoom out.
Sorry, Madam Rana, I just see
your slide.
Slide.
Live demo, your drawing. You do show your drawing?
Yeah, I'm sharing infrastructure.
You have to okay.
Okay, now can see?
On the screen.
Now can see the
No, still cannot see.
Still cannot see.
Now can already.